We want to use Euler's method with step size 0.5, which means delta x equals 0.5, to compute the approximate y values, y sub 1 through y sub 4, of the solution of the initial value problem given the differential equation where y of 0 equals 4. Euler's method is a method used to approximate a solution to an initial value problem. The method starts at a point in a slope field, usually given by the initial condition, and takes small steps of x equal to delta x. The slope is updated at every new x value, and the size of delta x determines the accuracy. So our differential equation is in the form dy dx equals f of x comma y, and y of x sub 0 equals y sub 0, with step size equal to delta x. So now we'll go back to our problem and follow these three steps for each approximation. And again, notice how we were given the step size is equal to 0.5, so delta x equals 0.5. Let's set this up on the next slide. So the first step is to find x sub n comma y sub n, which should be the point x sub 0 comma y sub 0 given by the initial condition. So because y of 0 equals 4, we know x sub 0 comma y sub 0 equals 0 comma 4. Next we want to find the slope at that point, which would be given by f of x sub 0 comma y sub 0, or in our case, f of 0 comma 4. So the slope at this point is equal to f of 0 comma 4, where f of x comma y equals 2 plus 5x plus 2y. So the slope is equal to 2 plus 5 times 0 plus 2 times 4, which equals 10. Now we have all the information we need in order to find the next point, which would be x sub 1 comma y sub 1. Notice for x sub 1 comma y sub 1, we would have n equals 0. So for x sub 1 comma y sub 1, we'll first find x sub 1, where x sub 1 is equal to x sub n would be x sub 0 plus delta x, which would be 0 plus 0.5, which equals 0.5. So the new x-coordinate is equal to 0.5, and because delta x is always 0.5, to find each x-coordinate, we always just add 0.5. Now let's find y sub 1. Y sub 1, the new y-coordinate, is equal to y sub 0 plus f of x sub 0 comma y sub 0, which we already found here, times delta x. So we'd have y sub 0 is 4, the previous y-coordinate, plus the slope at the point 0 comma 4, which is 10, times delta x, which is 0.5, which gives us 4 plus 5, which equals 9. So x sub 1 comma y sub 1 is 0.5 comma 9. Now we're going to go ahead and find the x-coordinate as well as the y-coordinate for each approximation, even though our question only asks for the y-coordinates. Before we go on though, let's look at what we did graphically. The given differential equation generates the red slope field. The initial condition y of 0 equals 4 gives us this first point, which is this blue point, 0 comma 4. Our first approximation was this point here, where to find the x-coordinate of this point, we started with the previous x-coordinate and added delta x, which is this horizontal distance. And then to find the new y-coordinate of this point, we took the previous y-coordinate and added this vertical distance here, which is equal to the product of the slope at this point, which is f of x sub 0 comma y sub 0 and delta x. So for each successive approximation, to find the x-coordinate, we always take the previous x-coordinate and add delta x, and to find the new y-coordinate, we always take the previous y-coordinate and add the product of the slope at the previous point and delta x. And all this is labeled here. Notice how our next three approximations will give us these 3 points. So notice how our approximate solution is not the best, because this blue function is the actual solution. If we wanted to have a better approximation, we'd have to make delta x smaller. Now going back to our work, so remember our next step here is to find the slope at this new point, which is equal to f of 0.5 comma 9, which would be 2 plus 5 times 0.5 plus 2 times 9, which equals 22.5. So x sub 2 comma y sub 2 is going to be equal to, well, we know x sub 2 is going to be equal to x sub 1, which is 0.5, plus delta x, which is also 0.5. So x sub 2 is equal to 1. And now y sub 2 is equal to y sub 1, the previous y coordinate, plus the slope at the previous point, which is f of x sub 1 comma y sub 1, which we already found here, times delta x. So y sub 2 is equal to 9 plus 22.5 times 0.5, which comes out to 20.25. So x sub 2 comma y sub 2 is 1 comma 20.25. Now we'll find the slope at this new point, which would be f of 1 comma 20.5. So f of 1 comma 20.25 is equal to 2 plus 5 times 1 plus 2 times 20.25. This comes out to 47.5. So now we can find x sub 3 comma y sub 3. Where again x sub 3 is equal to x sub 2 plus delta x, which would be 1 plus 0.5, which equals 1.5. And now y sub 3 is equal to y sub 2 plus f of x sub 2 comma y sub 2 times delta x. So we'd have y sub 3 is equal to y sub 2 equals 20.25 plus f of x sub 2 comma y sub 2 is f of 1 comma 20.25, which is 47.5 times delta x. To save some time, I've already worked this out. It comes out to 44. So x sub 3 comma y sub 3 is 1.5 comma 44. And now we need to find the slope at this new point. So f of 1.5 comma 44 is equal to 2 plus 5 times 1.5 plus 2 times 44, which comes out to 97.5. And now we can find our last point, x sub 4 comma y sub 4. X sub 4 is equal to x sub 3, which is 1.5, plus delta x, which is 0.5, which gives us 2 for x sub 4. Y sub 4 is equal to y sub 3 plus the slope at x sub 3 comma y sub 3, which is f of x sub 3 comma y sub 3 times delta x. So y sub 4 is equal to, again, y sub 3 is 44 plus f of x sub 3 comma y sub 3 is 97.5 times delta x. So y sub 4 is equal to 92.75. So we found our 4 points of our approximation. Going back to the graph just for a moment, these are the 4 points that we just found. Remember, our question does only ask us to enter the y values. So y sub 1 is 9, y sub 2 is 20.25, y sub 3 is 44, and y sub 4 is 92.75. I hope you found this helpful.